In 2016, Maverick Applied Science developed the Plant Engineers FRP Forum to create a platform where plant engineers could come together for in-depth discussions and to improve their work and knowledge of non-metallic piping and equipment. After the success of the initial Plant Engineers Forum, Maverick decided to offer this training yearly. The third annual Maverick Applied Science FRP Plant Engineers Forum was held on May 9th and 10th, 2018. This year's forum included presentations by key Maverick employees, along with a broad group of industry leaders. This year's topics included what proper non-metallic equipment purchasing specifications should include, how to choose the proper materials and manufacturing methods, how to design internal structures, and how to choose the correct codes and standards for fabrication of your non-metallic equipment. Finally, we also included some inspections of non-metallic equipment. Since everyone was not able to attend this forum, Maverick would like to share some of the offered presentations to the public. Thank you for your interest in Maverick Applied Science.
This is about outage inspections. So this is about when you call me to your site and come look at your tanks. You've asked me to give you an assessment of your vessels. For the most part, this is what you should kind of check for to keep an eye out while you're out there doing your own vessel assessments, and the things that if you see them, you may want to call someone else to make sure. Just good reference. These are chlorine dioxide storage towers. This is the installation in 90 or 91, and this was 3 months ago. So, still standing. The goals of this presentation are to teach you enough to know what to look for. What are critical things in an inspection? And when you see those critical things, then to be able to take them either within your own internal company to a subject matter expert, or to find another subject matter expert who can confirm your findings or hopefully refute your findings. The presentation is broken up into two sections, kind of external inspections and internal inspections. External inspections give you good information on the basic structural integrity of the vessel, and internal inspections will give you a good basic understanding of the corrosion and erosion that's going on inside your vessels. Where to start? It's always important to know, if you can, what you're looking at. So before you even go inside the vessel, you want to try to find a drawing. Try to find some specs, how the vessel was built. Try to find what's in the vessel. Because otherwise, when you walk up cold to a vessel, if you don't know anything about it, you really have to take your time to do the inspection. And so you have to inspect every surface. That's a good example. These tanks we were called out to do an inspection on. They looked outstanding. Horizontal pressure tanks. One of them had a significant structural issue that had to be repaired that we found out after inspections. And the tank on your right looks terrible. Looks like it's about to come apart. The liner's coming out of it. If you learn a little bit more about the tank, it's a brine saturator. So what you see here is the liquid level. That's salt being saturated, and that's salt stuck on the wall. If you didn't know that, you might be ready to throw that tank away just based on your visual observations. So you want to try to find out something about what you're looking at. First thing I look for, just as probably all of you should, is a leak. Leak is an obvious path. It's an obvious problem. If you see in the middle of the wall of your scrubber vessel something coming out of it, odds are it's coming from the inside out. There's probably no reason for a straight line, somebody to drop a leak on something on a tank like that. In the middle, that's sodium chlorate leaking out of the lifting lug. This is a sulfuric acid tank. No obvious leaks, but there's no foundation left. Sulfuric acid eats concrete, so that's a pretty good indication that something's going on in that tank. A lot of times too, if you're doing your implant inspections, you'll see leaks that I won't see. Because when I come to a plant, hopefully the equipment is locked out, tagged out, cleaned out, everything is ready for me to do an inspection. But at that point, I won't see your physical leaks. So if you're walking around your plant and you see something coming out of your tank, take a picture of it, note it, let me know. That helps me. Flanges. On external inspections, flanges are always a good place to look, because virtually every fiberglass tank out there, if you look hard enough, you'll find a crack in a fiberglass flange. There's a lot of reasons for it. I'm I'm not a fan of raised face flanges like this, or flat face flanges mounting to raised face equipment. You will break your flange. It's a matter of time. And these flanges, you can't just come back and put a putty bead on the outside and seal them up. So with a fiberglass flange, when it's cracked like that, you lose faith in it, you take that entire flange off and you start over with a new flange. Now you have another secondary bond in your system that's had to be put in the field. Not good ideas. And two, when they pull off the manway cover, you can take a look inside the manway cover a lot of times and get some idea of what the inside of the tank is facing. Okay, gussets and bolting is a big deal with flanges, and we spend a lot of time talking about flanges because flanges get broke a lot. These flanges are not going to be there when the truck arrives. Your best bet is that they'll be dangling, so at least you have the flange to reinstall. Anything that's heavy, a big valve like this, should not be supported directly on the tank flange. You need independent supporting of piping and tank flange and big valves, because otherwise what happens is you crack the back of the flange. I watched this flange be replaced about 3 weeks ago in a pickup. Platforms and ladders are a big deal because typically they're safety related issues. So if you come up to a site and you're doing an inspection and really you just focus on the tank and you don't think about the other issues, the platforms and ladders and things like that. I've climbed ladders before and felt the entire halves of the ladder flapping loose in your hand. The clips, the mounting clips of the ladder come off the exterior cage. Again, those are safety issues and those are immediate issues you have to bring up. But sometimes a lifting lug from 20 years ago shows a crack in it. You're probably not going to lift that tank again unless it's to rip it out. In that case, you probably don't care. You're not going to use those lugs again anyway. It does indicate that there's an issue because there's no reason for that to have cracked. Thermal expansion maybe, but if I'm not going to use it again, I wouldn't worry as much. But anytime you see any crack, whether it's in a pipe bridge, a temporary support for a pipe bridge, or a lifting lug, you want to try to figure out why. Hold down lugs. Vessels have a myriad of types of hold down lugs. Virtually every manufacturer that's here today has a different style of hold down lug and a different method. I can't say one works better than the other, but it depends on the size of the tank sometimes too. But when you're out doing your inspections, you want to make sure that the nuts are at least snug, that you're not fractured your laminates. This is actually the clip welded onto the tank that the dog ear, the dog is holding down. Well, it's obvious that the clip isn't holding on anymore. If they're double nutted, you want to make sure the double nuts are tight. And sometimes you just shake your head and take a picture of it. If you see deformities in your vessel, that's an issue. Vessel should not buckle. Daryl's talked a little bit about the knuckle regions in the past, and the knuckle regions on the tank are pretty high stress. They see a lot of action, a lot of movement, and a lot of stress. So you really want to inspect those knuckle regions if you can. Sometimes when they install a tank, they'll grout around the knuckle region and pretty much encase it in concrete. It's probably good for the tank. It's not great for inspections, externally anyway, but it's probably good for the tank. And sometimes you see a tank where the windings are up so high and the lugs have been wound right onto the back of the corrosion barrier basically, that you know this is pretty much all just corrosion barrier. And that's what's absorbing all the flex. Secondary bonds, again, we're just on external right now. We'll do a little bit on internal in a minute. Secondary bonds, you always want to check all the secondary bonds, make sure there's no leaking, make sure there's no loose edges, no delaminations, no obvious signs of stress where that nozzle's been racked or pulled around. And that includes every nozzle, manway, rib overlays, the top overlay, the bottom overlay. Every overlay you have to put your eyes on and confirm that they're in good shape. External bar calls are neat because you can get some really high numbers sometimes, but they're almost worthless. If the outside of your tank is not cured and hard at that point, you have some significant issues beside the bar call. Ultrasonic thickness checks, we do those quite often. You can only really do the wall The vessel shell, it is very difficult because the ropiness of the exterior of the vessel makes it hard to couple. UT likes flat things to put the puck on to get the transducer against. If it's not flat, if it's not able to send the pulse through and receive the pulse back, it's worthless to you. So there's quite a bit of difficulty that goes into UT. You can get some good thickness numbers out of it. I've heard people say that they can give you estimated life. I would say that you can give me an estimated life perhaps underneath that transducer. But if you tell me that the estimated life of my vessel is 20 years based on the shell, I'll tell you that typically shells don't fail. Typically bottoms fail, secondary bonds fail, and none of that's being checked any other way. External damages. Sometimes it's not even the fault of the tank when something happens. Sometimes a sulfuric acid pipeline above it leaks down onto the tank and eats the tank from the outside in. Unplanned. Sometimes they come back and they can't get a torque wrench. If they use the torque wrench on a nut, so they decide to grind holes in the gusset so they can get the wrenches on. Sometimes you see a crack on the outside of the tank and it looks catastrophic before you realize it's an insulated tank, and that crack you see on the outside is actually an expansion joint where the sleeve over the insulation is being allowed to expand and contract. But quite often I'll come to a site and someone will take me out to their tank and point to that and say, see, that's why we brought you. And I'll be able to hand you a business card and shake your hand and walk away. Fiber bloom. We talked about UV damage. UV damage is real. It is typically a surface phenomenon. It's kind of like surface rust from my understanding. What you see is the resin has been damaged by the ultraviolet lights and it's been basically disintegrated. But what happens is then you get down to the first layer of reinforcement, chop strand mat in this location, and it reflects the sunlight there. And it won't allow the sun to keep penetrating through the glass to get more resin. So that's why it's primarily a surface phenomenon. I have never seen a vessel fail because of fiber bloom. Nameplates are a big deal to me because nameplate is a legacy of the vessel. Vessels don't always maintain their purpose that they were originally purchased for. But I would tell you that within about 5 years, every nameplate I've ever seen that's been laminated into the wall of a vessel has disappeared. You can scratch them and repaint them with some clear resin and possibly bring them back out so you can see them. But if you have a nameplate like that, nobody's ever going to doubt it. And I don't know that these nameplates cost that much more than these nameplates as long as you ask for them. I don't purchase them. But on a $20,000 tank, a $500 nameplate can't do that bad for you. If you have agitation, you're going to want to kind of check special regions even more carefully, knuckle regions and things like that. Because we need to go inside really to see the baffles and to see anything internally, especially on an agitated tank, because there's a lot of actions, weird actions in an agitated tank that you just have no idea what they are from the outside. And you really don't want to use the acoustic method of listening for the baffle wall banging inside your tank during operations. And this is a natural habitat of an inspector, waiting on a hole watching a sniff. 2 hours worth of wait for 15 minutes of inspections. I really wanted to fly these pictures in. One day I'll have Daryl teach me how to do that, to make it a little more pop. Because this is a good vessel. They wouldn't tell me any of the history on this vessel. I have no idea what it was. It's a paper mill vessel. They told me it held distilled water. Simple. Distilled water, you know, your first thought is fairly light service. I'm not gonna have to worry too much about this one. Outside looked perfect. Go inside and realize that there was pull-through beams welded to the wall at one point. And one of the pull-through beams had been removed, it looked like, by a jackhammer. This is structural windings behind the corrosion barrier that's been ripped off when they tore the beam back off. Afterwards, I found a couple of people to talk to and found out this used to be a scrubber. Okay, repurposed vessel. But again, a scrubber that's repurposed for a water tank, you wouldn't worry too much about normally, just on the outside of it, until you realize that there may have been some damages done to it. So, never assume. Just because it's a water tank and it was built as a sulfuric acid scrubber 20 years ago, it should work. That's not always true. If you can find out information on the vessel, what I was saying about helping you with your inspection, if I know it's a slurry vessel or something like that, I'm expecting abrasion, and I'm going in looking for abrasion in certain places. Abrasion is going to happen on any surface that's up, that's quick, an impingement point. So there used to be a secondary bond across this joint here. You can see the remnants of it there, probably at an overlap. And you can see the joint and the putty starting to crumble out. So that joint is completely exposed. Whatever's inside that tank is going through that joint and hitting the exterior laminates. And if you go in and you find blisters, say it's an HCl tank that runs hot, probably going to expect some blisters inside of it. When you go inside and you see blisters, don't just say, yep, your tank is blistered. Measure them. Find out how big they are. Even if it's just averages. You have 6 blisters, roughly a ½ inch diameter every foot, to give people an idea of what it actually is, instead of, your tank is blistered. Okay, how much? While you're inside, you'll see damages occasionally. Sometimes it makes no sense. I can't explain why these blisters came in. Blisters typically are round. They don't form like that with irregular shapes. Something happened there, possibly an external impact to pop that liner loose. This is vertical cracking, axial cracking in a vessel. It's not uncommon to see in a vessel that sees thermal shock. So you have a sodium chlorate vessel that is at ambient temperature at 50 degrees, and your sodium chlorate comes in at 180 degrees. You have to keep it hot to get it pumped in quick. So that vessel in about 15 or 20 minutes goes from 50 degrees Fahrenheit to 180 degrees Fahrenheit. That's a pretty good thermal shock for a fiberglass vessel. Corrosion, that's obviously, this is Nexus Veil. I don't know how well you can see it here. That's what's left of Nexus. Outside the sealing rings where the gasket held it out, looks good. Inside the ceiling is corrosion damage. And then one other thing that I try to teach our inspectors too, and if you do this, if you take a picture and send it to me, do this. Put something in that picture that gives me scale. Because if you just send me that picture, I don't know if that crack is a ½ inch diameter or half of your wall is off your tank. So typically, we'll put a hand in it. If there's nothing else around, put a couple of fingers in it, point to what you're doing to give you a scale. I know that that flake out of there is about the size of a fingernail now. But if I didn't have my finger in there, that could be dollar bill size. Knuckle regions interior are critical to look at. We see a lot of damages on interior knuckles, especially on big tanks. Especially on big tanks that are thin wall. You'll see cracking right in the knuckle. You'll see delaminations where the secondary bonds are coming loose. You'll see floor damages often. It's not uncommon that the floor sees the worst service. It's almost always wetted, and it sees a lot of action. And if your foundation is not straight, and you end up with flex in your bottom, that every time you fill that tank and drain that tank, it flexes back and forth, back and forth. And that flexing action will wear your tank out. And I put this picture in here because this is a pet peeve of mine. If you call me and come ask me to look at your tank and you have 6 inches of water in the bottom of your tank, I'm not sloshing through the bottom of your tank to find out if the bottom's good. It makes no sense. I can't use my bar call down here because I'm not sticking my arm down in whatever that is. Sure, it's water. It burns, but sure, it's water. So, and if you do find problems with the floor, try to make a map as to where you have high spots. That way the people coming back can know where to grout. Baffles, like I've talked about, baffles are a big deal. They're an important part of a vessel, and they need to stay stuck to the wall. So the most important part of a baffle is the surfaces that are in the flow, make sure that they're not eroding badly, and then wherever the clips are attached, make sure the clips are still well attached. Dip tubes and support guides in the bottom. Again, these are in the bottom of a vessel, so they're going to see a lot of action. They're typically not structural. They're a lot of mat because you want them to be as corrosion resistant as possible. But if there's a lot of movement inside that tank or a lot of movement of the dip tubes and things, you'll see damages in those. One thing that we always stress to our inspectors is not to assume. Put your eyes on it. Whether you think you know it's right or not. This is a good example. This is one of my inspections personally. When I was inspecting this tank, this is a tall oil tank in a paper mill. This farthest nozzle here, I could lean out over, tied off, I could lean out over the railing, and I could see underneath, see the structural laminates, nozzle looked good. All those nozzles look good. Had them build me scaffold inside the tank. This tank is about 40 feet tall. So that's a significant amount of scaffold they had to build inside this tank for me. It's not easy sometimes to get you to build me scaffold inside your tanks because it takes time. I understand that. So I climb up my scaffold and I look at my top nozzles on the roof. This was the first ever inspection of this vessel. That's how I got them convinced to do this good of an inspection. Come up, look at all my secondary bonds. All the laminates look good. Everything's down tight. I see no problems at all. But I decided to look up in the nozzles to make sure. The nozzle was getting eaten up. So whatever they were injecting through that nozzle was destroying that nozzle. By the time I came back in 18 months, they probably wouldn't have scaffolded for me again because that's the second inspection. I've already proved to them that that tank's fine. So now, next 18 months, that nozzle's pretty much ate up. The welds are starting to go away, and now everybody wonders what happened. So you have to do your due diligence and look everywhere. Look inside the nozzle maps. Because process nozzles, a lot of times, who knows what's coming in that nozzle? Could be sulfuric acid coming in. The piping outside is metal. But they're putting it through a fiberglass stub flange. Now, they did good things. They built penetrating nozzles in the roof so that it didn't just run down the wall. But you have to cover everything, even the insides of nozzles. We take a lot of internal barcode readings because for us, if you hire me to come do your inspections periodically for you, we can track the hardness of the interior section of your vessel. I can tell you if you're starting to lose structural rigidity of your liner because your barcode hardness will go from 30 to 25 to 20 to 15 to 10. And if we do inspections right and work with you right, you can guide your maintenance crews to know when is the time to fix that tank. And it doesn't have to be a catastrophic fix. You can plan for a maintenance outage. You can save some money that way. You should take barcode readings on all major areas, even the top. I forget who, maybe it was Mike was talking, the difference in gas and liquid is pretty significant. So just because you're getting good barcodes down here, doesn't mean you'll get good barcodes on the top. So you want to try to track top, maybe 2 or 3 sections of a big vessel shell, and then the bottom also. And again, if the bottom of your tank has 3 or 4 inches of water, I'm not sticking my arm through it to take barcodes. Internal packing levels are a big deal to me because I stand under a lot of these packing levels with 20 feet of packing standing over my head. And nobody ever pulls the packing out for you when you do a vessel inspection because it's expensive. However, here I stand 20 feet below that packing, assuming that ledge is in good shape. The ledges aren't always in good shape. So sometimes when you pull out the packing of this vessel, you want to go inside there and do inspections also. And I know packed vessels typically don't get unpacked often, but anytime you have a concern, this particular vessel, just about a foot above this is where that first white leak was I showed you. Next year, they'll be removing the packing for me and I'll go up inside there. But these packing levels are structural. They're important. Daryl's talked about them on his engineering and design. And you want to make sure that they're still there. Abrasion resistance is a big deal, especially when a tank is agitated. So everything you see in these pictures is basically wear and agitation. This particular tank had a agitator that had a base mount to it also. So we had gone in one time and the base mount was missing. It was just flapping in the wind. These are actually holes through wall, through the bottom. And then these are complete through the corrosion barrier into the structural wall of the vessel. I left this vessel assuming that they were going to clean that vessel up, do some repairs. Vessel went back in service. Sometimes all I can do is give you guidance. Mud wells and feed wells, typically they're not designed for a one-sided loading very much, but when you drain your tank out, if you don't drain out your feed well, you'll have water full of that. And I can't expect that either when it's full of water. So, but you want to try to inspect those differently because those are process parts of your vessel. So they're going to see different kind of loadings than most other things. Reporting is a big deal to us at Maverick. We kind of pride ourselves on our reporting. It's an issue of being an engineering-driven company.
It's not an issue.
No, it's not an issue. Not for the guy that doesn't have to write the reports. So we got called in for a consultation for a second opinion on the job, and I asked them to send me the previous inspection report so I could review that and see what I was getting myself into. So I got an inspection report that was 10 pages long, but it was 2 pictures per page with captions, and that was it. I didn't know who wrote the report. There was no conclusions. There was no anything about the tank, nothing. So we got called in for a second opinion and finished the job, basically. But for our reports, we're going to give you ideas of what happened, you know, what we saw, whether it was good or bad. We try to take pictures of good things too and put them in your reports. It doesn't all just have to be broken stuff. So our reports are pretty detailed, and I would recommend that anybody you have doing inspections for you should provide you detailed reports, because if they're not, you're not getting your money's worth. This is your legacy here. This is what you're going to keep in your files to keep passing down to people to continue that knowledge. This doesn't help anybody. So, fiberglass tanks are critical assets in your plant. Typically, fiberglass tanks don't hold milk or honey. They're going to hold something pretty nasty. Treat them like critical assets. Take care of them and look out for them. And if you see a problem, please call somebody. All right? Thanks, everybody. Glad you came.